We are picking up lesson 1.2, part 2, correct?
Yeah.
And in our last few minutes of class on Friday, I used it to just kind of go over the idea of what we mean by bounded. I'm trying to remember how the vocabulary reads. Bounded below, bounded above, bounded, or not bounded. Okay, so if something is bounded below, there is a certain point. Whether it's like a minimum here, whether it's an asymptote, there is a certain spot on the graph where nothing goes below. So that's bounded below. Bounded above, just the opposite. There's a certain spot where the graph does not go above. And as I said, that could be a point it doesn't go above. That could be an asymptote things don't go above. Just there's a certain, we can say nothing goes above this x value. Or excuse me, y value. Not bounded is going to mean it's not bounded above or below. Okay? So not bounded is what I have here. I think the book uses not bounded. They could use the vocabulary unbounded, but I think it's not bounded. Okay? And then bounded means there's a max point and a min point that we don't go above and below. So it's bounded. You would also, I believe the book says something about bounded on its domain. I think that's similar. That's equivalent vocabulary. Okay? We can look at vocabulary when we get to homework time. So, examples. Identify each of these functions as bounded below, bounded above, bounded, or not bounded. I just want to know what type of bounding it is.
It is bounded below.
It's a parabola.
Wow, I'm impressed. We didn't even graph it?
I graphed it.
Yeah.
Oh, I graphed it. Oh, man.
Yeah.
I was briefly impressed here. Now, and in reality, okay, yes, by all means, do I want you guys graphing these? Yes. In reality, though, 3x squared minus 4. I believe we know, that is a parabola of some sort, right? That opens right side up. If it's a parabola that opens right side up, then there's going to be that minimum point that we never go below. So, my answer for this one is that yes, it is bounded below. Now, not that you have to, but if you had to, where is it bounded below?
-4.
At -4, because how low does that parabola go? -4. I know that because my parabola is moved down 4. I also would know that because my calculator is showing me that if I graphed it, yes? Okay, so I'm just going to say at y equals -4. Again, that's not the required part. That's just useful information. Okay, B. Do you know what B looks like off the top of your head?
Yeah.
Not gonna lie.
Off the top of your head without looking at the graph?
No, you didn't. It's like a circle,
In a circle.
and then a circle inside the circle. It's like a donut.
Oh, it's one of.
You guys got something weird
It's
going
like a
on.
snake.
I'll go with the snake definition. I don't see any donuts happening here.
How we done is
I was close enough.
I think
Okay,
A little bit.
so we have a graph. And one thing you might want to do, you could if you want to, if you kind of want to see what's going on in there. You see the visual here. If you go to zoom in and then hit enter an extra time, that will zoom in if you kind of are curious what it's doing there. But we just have this graph that's kind of going along here. Something like that. That's my best attempt at drawing it. Now, what are your thoughts about bounding?
Is it bounded?
Does it have a max point and never goes above?
Yeah.
Does it have a min point and never goes below?
Yeah.
And what's it look like it's doing as it heads out to left and right?
Keep going.
Just keep going.
Keeps going probably along a what?
Asymptote?
A horizontal asymptote, yes? If visually what we can see, when we can see that bulk of that graph, it's continuing on. So yes, we have a high and a low, and that one is bounded. I just have it written as bounded. As I said, the homework might talk about bounded on its domain. I have to look at that to know for sure. Okay? Okay. Now, and I maybe should have started off. Do we even remember what we talked about last week on Friday?
Oh, like the holes and the what's the other one?
Yeah. So just as a quick reminder, before we go to our last topic, Friday we started talking about continuity. When your denominator equals 0, there's either a whole or a vertical asymptote. If there's a factor that can cancel, it's a whole or a removable discontinuity. If there's not a factor it can cancel with, it's a vertical asymptote or non-removable discontinuity. And then we reviewed increasing and decreasing. I say reviewed because that was the beginning of the year in Algebra 2. Just remembering to use your x values to write those intervals. We just talked bounded. And now we're going to talk about extrema. Extrema. You already know what extrema are. You just might not be familiar with the word extrema. Extrema are the hills and valleys of our graphs. A local maximum or minimum is one of the hills or valleys of our graphs. An absolute maximum or minimum is the highest or lowest point that the graph ever goes. And so we're going to spend the rest of this lesson talking about mins and maxes. We do need to distinguish the difference between what is an absolute min or max versus a local or relative min or max is the vocabulary we'll also run into. But you guys have the idea of a min or max, right? So if, I'm going to give you a couple of pictures here just for reference. What does this right side up parabola have? It has a what?
Minimum.
A minimum.
Whatever.
Does anything else on this graph ever go below that minimum?
No.
No, that is the absolute lowest this graph ever goes, right? So this is what we would call, this is an example of an absolute minimum. Because none of the rest of that graph, none of the other pieces go any lower than that. So that's an absolute min. Now, if I flip this parabola, guess what I'm drawing?
Max.
A max, and what kind of max?
Absolutely.
This is an example of an absolute max. Because none of this graph ever goes higher than that y value there. Now, for distinction here, let me draw a curvier graph here. On this graph, do you see a max?
Yeah.
There's a max here. Do you see a min?
Yes.
Yeah. Okay. Now, here's the deal. That max that I put that first dot in, is that the highest point that graph ever goes to?
No.
No. It's the highest point on this section of graph. Okay. In this neighborhood of the graph, you'll sometimes hear them talk about the neighborhood, but in the local neighborhood, that's the highest point. Now, out over here, the graph is going to go higher. But because this is a max in this area, this is what I'm going to call a local max. Okay, it's still a max, just like an absolute max. It's just local because it's a max only to that area. And of course, what am I going to say over here then? Is that the lowest point of the graph? No, it is a minimum. It is the minimum in that neighborhood, in that area of the graph, in that section. But if you go over here on the other side of the graph does eventually go lower. Okay? But basically, when you have the bottom of a valley or the top of a hill, it's going to be some type of min or max. Now, this book appears to use the word local. If you ever hear the word relative min and max, relative is another word for local. Okay? It's a min or a max relative to that area. Absolute is always absolute. Okay, got it? Okay, so our big example here. Decide whether this function has any local maxima or local minima. If so, find the values and state whether or not the values are considered absolute. Now, when they say find any local maxima and minima, what are they asking me to find? My minimums and maximums, yes? Be aware, what word did we start this part of the lesson with? Extrema. Okay, I'm going to draw you back to that word just because that's one of those words that you'll see it on a quiz or a test coming up and you'll be like, extrema? Did we ever learn extrema? Extrema is a fancy way for me saying find your mins and maxes. Okay, extrema, your extremes, or your mins and your maxes, okay? Okay, so what do you need to do to find your mins and maxes here?
Graph.
You probably need to graph it.
Oh,
So let's all graph it. Everybody needs to graph this because we have a skill to learn. I do zoom 6 to put me back on a normal screen. Okay. Does your screen look something like my screen?
yes.
Okay. Notice my graph goes off the screen, yes? What are we guessing most likely it does? It just goes down a little ways, come back up. Now, do we know that for sure? Well, technically I'm going to say no, but can we figure that out for sure? Okay. There's my, just because I need to label and point some things out, there's my basic drawing of the graph. Now, okay, first of all, before we do anything, because here's the deal. We have to label our local mins and maxes, but we also have to find the values, which is where the calculator comes into play, where I said we're going to learn a new skill. Before we do that, we probably need to be able to see all of our mins and maxes, yes? We're missing something, aren't we? What are we missing? We're missing a minimum, yes? Okay. Now, a couple of different ways you can handle this. You can try just changing your y min and see if you can guess and get it low enough. Or you can zoom out, and then I'm going to readjust my graph after I zoom out. But so I'm going to zoom out is a technique I'm going to take. I'm going to go into my zoom menu, and then I'm going to go to number 3, and I'm going to hit enter. Now, has it zoomed out yet? No, it's waiting for me to move the cursor to show them where I want to zoom it out. Usually, unless I want to change it, I'm just going to hit enter again. Okay, it zoomed out, didn't it?
Yes.
Now, it zoomed out, which is good, but I don't know about you guys, to me that graph is hard to read, yes?
Yes.
And there's lots of different techniques of how you could do this. I want to refocus on that specific graph. You remember me teaching you ZBox?
Yeah.
Okay. ZBox is a recommendation I suggest. So go into your zoom menu. ZBox is number 1, yes? And I'm going to hit enter. And remember, what you do is you're going to draw a box. So we're going to move our cursor to wherever you want a corner of your box to be. Well, I want to make sure my graph goes low enough. So I'm putting it down here. Okay? You can put it wherever. I'm putting my cursor there. And then I'm going to hit enter. And now I'm going to go to the diagonal corner of where I want the other part of my box. So I'm going to go over to the right. And I don't hit enter yet. Don't hit enter until we're done. And what I want is I want to be able to see enough of that graph. If I put my box something like that, can I see all my mins and maxes inside that box?
Yes.
Okay, not everyone's is going to be identical. But this is an option of how to do this. Okay? So once I have it set there, I have my box, I'm going to hit enter. Now my graph is going to draw, and I can actually see my graph in a good shape. Does that make sense? Did we get something? Did you get it okay? I wonder if you were on today. I taught it. I don't know. I don't remember what I taught it. I know it came up once. I taught ZBox once, right? Okay. And it's one of those things. I want to keep reminding you guys because if we only did it that once and you've already forgotten about it, you haven't used it since, right? So it's a good one. I like ZBox. It has good uses. Okay. So what do we need to know? Let's talk about this graph real quick. What do you see on this graph? Tell me what I can label. What? Absolute min. I assume we're talking about that value right there. That is going to be an absolute min because my graph never goes below it. Okay, good. That is the lowest point on my graph. We'll get number values here in a moment. What else can you tell me?
Absolute. No. Local max.
A local max, and it's local because there is a max. There is the top of a mountain, but the sides go higher, right? But that right there is a local max. I'm just trying to talk vocabulary with you right now before we find our numbers. And a local min? We already have an absolute min, yes? So it can't be another absolute min. There can only be one absolute. So we have a local min. Okay, guys. You got those values, yes? Or I mean, you got that vocabulary. It asked us state or find the values. Folks, we need to find these values. So, where do you remember seeing a min-max option on your calculator?
In the calc window.
In that calc menu, go into, same place we found zeros. So go into second and hit the trace button, which is the calc menu. It's the same place we have used to find zeros, yes?
Yeah.
And what do you notice?
There's a min.
There's a min and a max. Now, shall we start with min?
Sure.
Okay, so let's all pick number 3 together. Now, similar to zeros, it's going to ask you questions and walk through it step by step with you. So what's it asking me first?
Left bound.
Left bound. So, which minimum am I trying to find? We want to find this minimum, the absolute minimum down here.
Yeah.
So I need to move my cursor to the left of that point. So I'm going to move it, move it, move it, move it. Am I to the left of that absolute minimum? Yes?
Mm-hmm.
Okay, we're going to hit enter. Now it's asking me for right bound. So now what am I going to do? I'm going to move my cursor. There's my minimum. So I'm going to move my cursor to the right of that minimum. And I'm going to hit enter. Is that minimum below my 2 little dotted lines there?
Yeah.
Yeah. Now,
Oh, I didn't know.
next question it's asking is guess. What does guess mean?
Enter.
Technically, you can probably just hit enter again as long as you only have 1 min in between your lines. But technically, it's arrow back to that area. Now, am I done? No, because it still says guess. Have I found it yet?
Mhm.
Hit enter. How do I know I'm done?
This is minimum.
It says minimum. Our minimum should be pretty much identical. On occasion, we'll get weird glitches that happen, but our minimum's identical. Okay? So new technique. You have to be careful as you learn it that it doesn't interfere or intersect. It doesn't get confused with zeros.
This one right here.
Oh, okay, that's why you're, well, I'm getting ready to write down, yeah, looks good. I thought you were shaking your head like, no, mine doesn't agree, but okay. Okay, fair enough. So now, this is my absolute min, right? I have my answer key written to 2 decimal places. So the ordered pair here is negative 2.06 and negative 24.06, yes? Now, yes, I wrote the ordered pair. Technically, when you go to homework, they want the min or max value. The min or max value is technically the y value, because how low does it go is negative 24.06. Where does it happen is the x value. Okay? So that's a big thing to understand moving forward. But, if you put the ordered pair there, it's good. You've got the information. But you've definitely got to have the min value is this negative 24.06. Okay? Shall we try another one? I know it's another part of this problem. Okay, what do you want to find next? I'm going to go for the local max or the local min. And we have to decide, don't we? Or maybe but you personally have to. So, because if you hit min and then try and find the max, you'll get an error message. Because it can't find a min. It gets confused. So, okay. So I'm going to do second calc. I think I'm going to go and find my max now. So there's my max, number 4. Same exact questions. Left bound. If I'm trying to find this piece, this max right here, honestly you can be anywhere left of it, but I try and get somewhat close to it. Am I to the left of that max?
Yeah.
Yeah, so I'm going to hit enter. Notice my little line, that faint line shows up. Right bound. I'm going to move past the top of that mountain. Yes? I'm going to move to the top of the mountain and hit enter.
Got it.
Does your max agree with my max?
Yeah.
If you did the max next. Two decimal places. What do you have? .46 and 1.32. What is the max, the max value here? 1.32. And if you haven't, did you find your other min? Let me know if we're running into issues. I'll help troubleshoot. So, second calc. I'm going back to number 3 to find minimum. Left bound. I need to be left of that low point. Enter. Right bound. I need to be to the right of that low point. Minimum guess. And hit enter. 2 decimal places. I have 1.60, comma, negative 1.77. What is the actual min value there? Yes. Okay. So when it says find the values, those are your y values officially. Okay. It's not bad. So we did the second trace button, or in other words, the calc menu button, right? And then we went to min or max, depending on what you needed, right? So that's your reminder of where you went. Okay. Questions? Okay. You have some work time. 22 through 46 evens. There's probably, I don't know, like 3-ish problems on each section type thing maybe. Okay?